Now I'm going to show you distance-based outlier detection method, KNN, which is K nearest neighbor. In this particular instance, your KNN, it identifies outliers as the data point whose K nearest neighbors, they are far from them. So in this particular case, you can see that you have these normal points, then you have these points right here, these orange ones right here. And these orange points, you can see them, they're kind of like isolated by themselves. They're all by themselves. They are loner points. Same thing over here. You can identify like these red points right here. These are my outlier. These are basically all by themselves. On the other hand, these points right here, they all have neighbors. Okay, these points over here, they don't have many neighbors over here. So you are basically trying to find the points that do not have many neighbors. This is the idea of your KNN. Suppose you have a data given to you, this right here, and you have to find outliers over here. So in this case, each row over here, it represents your data point. So this is one data point, let's say P1, this is second data point, P2, P3. So each one of the rows over here, they are your data points. So let's start with the simple one, the distance based outlier detection method. The idea is this, that you compute the distance to the kth nearest neighbor for every single point. And if this distance is large compared to other distances, comparing with other data points, then it is likely an outlier. This is the idea of that. So let's understand this through an example. Suppose you have a data point P1 and you are choosing k equal to 5. So let's say you have 5 neighbors for P1. So let's say you have one point over here, another data point over here, another over here, another over here, and let's say you have another one over here. These are your data points. And let's say this distance is 2, this distance is 3, this distance, let's say, is 4, and this distance is 4, and this distance right here is 7. So in this case, you have 2, 3, 4, 4, 7. So the distance of this point P1 to the fifth nearest neighbor would be 7, right? Because this is your fifth nearest neighbor right here. So in this case, my P1 equal to 7. Then we do the same thing for the next data point. So let's say this is your point P2 right here. And we find its 5 nearest neighbors. So let's say this is 1, this is another 1, another 1, another 1, and let's say this one is another 1. So in this case, let's say this is one distance, this is another distance. Let's call this thing as P2. This is another distance, this is another distance, and this one is another distance. So let's say this distance is 1, 1, 2, and this is 3. And let's say this distance right here is 4. So in this case, the distance of P2 to the fifth nearest neighbor would be this one right here, the number 4. So in this case, my P2 would be 4. So in this case, this is the idea. You're looking at a distance. You're trying to compute the distance to the fifth nearest neighbor. Okay, and likewise, we can calculate the fifth nearest neighbor for each one of the points. So let's say for P3 is 11, P4 is 6. So that's my step 1. Step 2, then I sort this distance for all data points. So I'm going to sort this P1, P2, P3, P4 based on the distance. So in this case, my P2 will come first because this one actually is the least one, 4. Then P4 will be next because P4 is 6. So if you look at the distance for P2 is 4. The distance for P4 is 6. The distance for P1 is 7. And the distance for P3, the fifth nearest neighbor distance, is 11. So I sorted these points now. Then my final step would be pick up the top maybe 5% or top 1% or top 2%, depends on you. So in this case, I'm picking the top, let's say 5%, and that top 5% would be my outlier. Let's say my top 5% is this one right here. So P3 is my outlier in this particular instance. Now this distance, it has a special name. It is also called an outlier score. So the formula for outlier score is equal to the distance to the kth nearest neighbor. Now you can extend the previous idea to actually use the average distance. You don't need to find just the fifth nearest neighbor or kth nearest neighbor. You can actually do the mean of you can actually calculate the mean or the sum of the distance to the k nearest neighbor for every single data point. So the points with the highest average distance, they would be your candidates for being outliers. Now, this distance also has a special name. It's called outlier score. The outlier score would be equal to 1 over k times the sum of all the distances. Basically, you're taking distances of all the neighbors and you're adding them together and you're dividing by k. So let's understand this through an example. Suppose your k equal to 3. And so let's start with point P1. Let's say this is my point P1. So in this case, you find 3 nearest neighbors. So let's say my 3 nearest neighbors are this one, this one, and this data point right here. So you find the distance for each one of them. So let's say this distance is, call it 12, and let's say this distance is 10, and let's say this distance is 14. So I have three nearest neighbor for point P1, and these are my corresponding distance. Then you calculate the average of them. So in this case, I'm going to say 1 over 3 times, okay, then you add all the distance together. So you say 12 plus 10 plus 14, and then that answer will come out to be 12. So the score, the average distance of point P1 to the three nearest neighbor is 12. And this is how you get the average distance to three nearest neighbor equal to 12. So this is for point P1. Likewise, you can do the same thing for point P2. And then you calculate the average distance to the rest of the points. So let's say for point P2, this is your distance. For point P3, this is your average distance to the nearest neighbor. And likewise for point P4, let's say this is your average distance to the three nearest neighbor. Let's say you only have four data points in this particular example. So in this case, you can see that this particular point, 20, that's the highest number, right? So this guy, it seems like he does not have many neighbors because this guy is living very far from the rest of the people. This one only has 20. This one actually has the highest number, 20. So this would be a candidate for your outlier. So let's look at some of the limitations of KNN to identify outliers. Well, first of all, it is computationally expensive for large data set. That makes sense because each time for each data point, you're trying to find the nearest neighbor, right? So let's say you're trying to find five nearest neighbors. So you're doing this computation over here. You're calculating the distances of this data point with this nearest neighbor right here. So this is basically a computationally expensive process if you have a lot of data points. And then it is sensitive to choice of k. So just by changing your k equal to 5, maybe you go to k equal to 6, that would change your outlier points.